Assalamualaikum warahmatullahi wabarakatuh. So today our group will present about this project, the application of the heat transfer. Our group choose the boiler for this project. So first of all, I will introduce ourselves. So my name is AKMAL bin ZAINUDIN. My metric number 206737. And the second member is Muhammad AIDID bin Ammar FAUZI. The metric number 207065. And the last member is Muhammad Ammar SYAZANI bin AZREE with metric number 205727. So I will explain about the introduction of the boiler. All right, a boiler is in a closed pressure vessel. That means that water is converted to steam by adding heat from any sources such as coal, oil, or gas. In the boiler, in terms of the thermal power plant, that means steam is gathered and pressure before being released into turbine, which is transform the thermal energy into the mechanical energy. While in terms of the generator, which is connected to the turbine, transform into the mechanical energy into the electrical energy. So I will explain about the type of boiler. Boiler, they have two types. That means a water tube boiler, and the second type is fire tube boiler. All right. In the boiler, they have three heat flow. The first one is radiation. The second one is convection. The third one is conduction. I will explain about the radiation. Radiation is the process that continual energy exchange between the bodies using the electromagnetic wave without a change in the temperature of the medium. While the convection is the process that transfers heat by moving energy through a substance. For example, the steam boiler heating the surface are heated by convection from the hood flue gas. And then lastly, the heat flow is conduction. This means the movement of heat from one portion of the body to the another, or from one body to another in physical contact. I will pass the second topic to Muhammad AIDID.
I will go through the heat loss in boiler. So for the energy input, the energy is become in source of fuel. So the energy input will be 100%. So in the boiler, there will be heat loss such as flue gases in 80%. The heat loss in radiation and convection in 4%, and the heat loss in the blow down will go 3%. Therefore, the energy output for the boiler, there will be only in range 75 to 77%. Therefore, energy in heating medium, so such as steam. Next, I will go to the application of thermal boiler. So the benefit of thermal boiler, they're used in pharmaceutical sector because they can deliver temperature between -100 Celsius and 400 Celsius, enabling both heating and cooling activities. The benefit of thermal boiler is that it can run at high temperature and low pressure. So next, the solar thermal power plant. So as we can see, the solar energy collector will be collect the radiation from the sun, and the energy will go to the go through the water and use the energy for evaporator boiler. Therefore, the steam will go to the turbine, and the water in a hot temperature to change to the kinetic energy, and then the working fluid will go through the condenser and cooling tower. So that's when we can see in the evaporator boiler, the water through from cold to hot, hot to cold to hot, uh, and then go through the cooling water to cool down the water and go through in the repeated process. A thermal oil boiler is necessary to create a superheated steam to drive the turbine power generation. As a result, energy storage system may be heated during the day using a solar collector system. So that's all I can explain. I will pass the presentation to Ammar.
Thank you, AIDID. Now I will explain the example of calculation. A brick wall with a thermal conductivity is 1.3 watt per meter Kelvin with a 0.15 meter thick separate combustion gases in a furnace from the atmosphere air 30 degrees Celsius and the outside surface temperature is 100 degrees Celsius, while its emissivity is 0.8 and the heat transfer coefficient for the outer surface is 20 watt per meter square Kelvin. So the question is, we need to find the inner surface temperature of the wall and total heat loss to the surrounding by both convection and radiation per unit area. So below is the given that is given in the question. So for the atmospheric temperature and outer surface temperature, we need to change it from Celsius to Kelvin. So next is the question that we need to find, which is to find inner surface temperature, heat loss per unit area by convection and radiation. So for the first one, the heat loss by convection, as we can see here, this is the formula, and from the given, we just insert it, the value. Then from there, we get the answer is 1400 watt per meter square for the convection. And next is heat loss by radiation. This is the formula. So that here all the heat emitting by the wall will be received by surrounding by taking shape factor F is equal to 1. So from the given also, we can just insert it, the value in the formula, then we will get the answer, which is for the radiation per unit area is 495.693 watt per meter square. Next is the inner surface temperature, Ti. So from here, by energy balance, heat input is equal heat convection plus heat radiation. From the above, we already get the heat convection and the heat radiation. So from the value, both we can insert it in the formula, which is here. And because we need to find per unit area, so we got the convection per unit area and radiation per unit area. So from here, we just insert the value. Then because of Ti, we need to find the Ti, so we just rearrange. Then from there, we can get the answer is in Kelvin, 1895.993 Kelvin. So in Celsius is 380.033 Celsius. And that's all for the example of calculation. So in our conclusion is we learn more about the boiler and the fundamental principle underlying how heat is transferred within them, such as the mechanism of conduction, convection and radiation. And also we can minimize the global energy used to address environmental and energy related issue, and utilizing solar thermal boiler which run on sunshine. Sunshine is depends on the sun, as their primary energy source also can help us to cut back on our energy usage, and this will make the approach environmentally benign and a sustainable source of energy in the future to protect our planet from global warming. Thank you. That's all from us.